All right, let's dive in. Today, we're going to pull back the curtain on how the world's biggest apps, the ones you use every day, are actually built. We're talking about the architect's blueprint, the secret sauce that lets them handle millions of people all at once without even breaking a sweat.
You ever been just scrolling through your feed, minding your own business, and a thought pops into your head? How does this actually work? How can so many people be uploading, commenting, and liking all at the same time without the whole thing just crashing and burning? Well, that right there is the central puzzle of system design.
And guess what? In the next 5 minutes, we're going to break it all down. We're going to walk you through the exact blueprint architects use to build these massive bulletproof systems. By the end of this, you'll get the core concepts and, more importantly, the tough choices they have to make every single day.
Okay, so you know how every huge skyscraper starts with a solid plan, a blueprint? It's the exact same for software. And that plan starts with truly understanding the scale of the challenge and defining precisely what it is we need to build.
So what is system design really? Think of it like this. Building a simple app for a few friends, that's like setting up a small corner shop. Easy enough. But building an app for millions of users, that's like designing an entire shopping mall. You've got to think about everything. Traffic flow, what happens when a store shuts down, how you're going to add a whole new wing later. It's all about planning for that massive complexity and scale right from the very beginning.
The very first step, and honestly, this is the most critical part, is figuring out the requirements. And these come in two flavors. You've got your functional requirements. That's what the system does. The features. Like for Instagram, you can upload a photo. Simple. But then you have the non-functional requirements. That's how well it does its job. It has to be blazing fast, it has to handle the evening rush hour, and it basically has to always be open for business. And let me tell you, it's those non-functional requirements that really shape the entire design.
And why is this so important? Because the numbers can get absolutely wild. A quick back-of-the-envelope calculation for a service with, say, 10 million users could easily hit a peak of 100,000 requests every single second. Just think about that number. That one number changes everything. The kind of database you need, your server setup, the whole shebang.
So, once we know what we're building and just how huge it needs to be, it's time to make the big calls. These are the foundational choices. It's like deciding if our shopping mall is going to be one giant monolithic building or a campus of smaller, separate shops. One option is what we call the monolith. Picture a cozy little cafe where the kitchen, the cash register, the coffee machine, it's all one connected unit. It's super simple to get started, right? Everything's in one place. But if the coffee machine gets swamped, the whole cafe slows to a crawl. It's really tough to scale just one part of it. The alternative? Microservices. Now we're back at our shopping mall. The food court is its own service. The movie theater is another. The stores are all separate. If the theater has a huge line for a blockbuster movie, it doesn't slow down the food court at all. You can scale each part on its own. Now, it's way more complex to set up and manage, but that flexibility is a game changer.
Next big question, where do we store all the data? This brings us to the great debate, SQL versus NoSQL. Think of SQL databases as a bank ledger. They are super structured, with very strict rules. Perfect for things like financial transactions, where every detail has to be exactly right. NoSQL databases, on the other hand, are more like a massive warehouse. You can just dump boxes of all shapes and sizes in there. They're incredibly flexible and built to handle insane amounts of data, which makes them perfect for stuff like social media feeds.
And to make sure we can find anything in that database quickly, we use something called an index. It works exactly like the index at the back of a textbook. Instead of reading every single page to find what you're looking for, you just flip to the index, and it tells you exactly where to go. It makes finding data super fast. Okay, we've got our main building blocks. Now, how do we manage the absolute chaos of millions of users and all their data flowing through the system? Well, we need some specialized tools to direct all that traffic and keep things running smoothly.
First up is the load balancer. This thing is basically the traffic cop of the internet. Think about it. When a huge line forms at the grocery store, they don't just let it get longer. They open more checkout lanes, right? A load balancer does the exact same thing for servers, spreading all the incoming users across a bunch of them so no single one gets totally overwhelmed.
Now, to make an app feel lightning fast, you need a cache. The best analogy is a chef in a kitchen. They keep their most used spices right there next to the stove, not locked away in a warehouse out back. A cache does the same thing for data. It keeps the most popular, frequently accessed stuff in a super fast layer of memory, so it can be grabbed almost instantly.
But what happens when your users are all over the world? You can't have someone in Japan waiting for a picture to load from a server in California. That's where a content delivery network, or CDN, comes in. Think of it like a newspaper. They don't print them all in one city and ship them. They print them locally in every major city for faster delivery. A CDN does the same thing, storing copies of your images and videos on servers all over the globe so users get them from a location close to them.
And finally, some tasks just don't need to happen right this second, you know? Like when you upload a video, it needs to be processed, but you don't need to wait for it. For that, we use a message queue. It's just like a post office box. You drop a task, your letter, into the box and trust that the system will get around to processing it later. This is amazing for smoothing out huge spikes in traffic.
Now we get to a really crucial part of the whole design, building for resilience. See, at this kind of scale, things don't just sometimes fail, they are always failing. Something is always breaking somewhere. A great architect doesn't hope for the best, they plan for the absolute worst.
And the first line of defense is a simple but powerful idea: replication. You wouldn't keep just one copy of a super important document, would you? Of course not. You'd make a few photocopies and keep them in different places. In system design, you do the same thing. You store copies of your data on multiple servers. That way, if one server completely dies, the data isn't lost, and another one can just pick up the slack.
This really all comes down to a core philosophy, a mantra that every good system architect lives by. You have to design your system with the assumption that everything, and I mean everything, will eventually fail. Servers will crash, networks will go down, data centers will lose power. The goal is to build a system that can handle it all without the user even noticing.
So how do they actually do this? Well, they have a whole toolkit of tricks for what's called fault tolerance. They program in automatic retries, so if a request fails, the system just tries again. They use circuit breakers, which are smart enough to stop talking to a service that's struggling, giving it time to recover. They set strict timeouts, so one slow part of the system can't drag everything else down. And they run constant health checks on every component, like a doctor monitoring vital signs.
This brings us to our final and, I think, most important section. Because here's the secret. System design isn't about finding the one perfect solution that does everything. It's really about mastering the art of the trade-off.
Every single decision you make is a balancing act. There are no free lunches here. Do you want your data to be perfectly consistent across the globe, or do you need the system to be available 100% of the time, even if that means some data is a tiny bit out of date? Do you want the absolute fastest performance possible, or do you need to keep your server costs from exploding? See, there's no single right answer, only the best answer for the specific problem you're trying to solve.
And hey, if you ever find yourself in a system design interview, this is your roadmap to success. Seriously, start by clarifying the requirements and estimating the scale. Then, lay out your high-level architecture. Dive into the data model and the APIs. Talk about how you're going to scale it and how you'll handle failures. And then, this is the most important part. Always explain the trade-offs you made and why.
And let's end on that thought, because it's so true. There is no such thing as a perfect system. There is only a system of trade-offs. And understanding that, really understanding that, that's the real secret to mastering system design. Thanks so much for watching.